response question number 3. No calculator. That's fine. We don't need one. Calculators are for suckers. Anyway, this figure below right here shows the velocity v, also known as dSdt, also known as f of t, all these names, of a body moving along a coordinate line in meters per second. Answer the following questions based on the graph. Well, let me reiterate that this graph is velocity, not position, which is usually given to you as s of t. This is the velocity function. So anything that's positive is you moving forward. Anything that's negative is you moving backwards. So at this moment right here, you're moving forward at meters per second, 1 meter per second. Now you're moving forward at 3 meters per second. Now you're moving forward at 3.5 meters per second. Now here you're moving backwards at 3 meters per second. So when does the body reverse direction? Well, the body reverses direction at any time where it crosses the x-axis. Anytime there's a sign change is when it reverses direction. So to answer part A, there's a sign change at 4 and a sign change at 8. So A is going to be t equals 4 seconds and t equals 8 seconds. And that is because the body reverses direction anytime there is a sign change. And that occurs anytime there is a sign change. And that occurs when, you can see that I'm not really good at all multitasking. That occurs whenever you cross the x-axis. Now part B is asking, at what time or times is the body moving at a constant speed? Well, again, velocity is basically positive or negative speed. So when do we have a horizontal line for velocity? Well, that happens at once. By the way, the devil is going to tell you, oh, that's constant, isn't it? That's constant, isn't it? No, we're technically speeding up. The velocity at this moment from here to here is increasing. That's not constant. You're going from 1 meter per second to 2 meters per second to 3 meters per second, back down to 2 meters per second, blah, blah, blah. The only time where you're going to have a constant speed is in between 6 and 7. So the body is moving at a constant speed when t is in between 6 and 7 seconds. And that again is because the velocity is a horizontal line. So at this moment, we're going backwards at 3 meters per second for a whole second there. And that's it. That's the only time that happens. That only time. So that's how you answer B. All right, so I switched over to the next slide, and the question that's being asked is the same thing, same exact picture, just, cleaned everything up here. What is the body's maximum speed? Provide the explanation for your answer. Well, the body's maximum speed is actually 2 times here. Now, velocity can be positive or negative, right? A positive velocity means you're moving forward. A negative velocity means you're moving backwards. Speed is the absolute value of velocity. So this is going to happen twice. So for C, you have at t equals 2, and when t is in between, 6 and 7? We did that before. The speed is 3 meters per second. Okay, and again, the explanation for that is because speed is the absolute value of velocity. Now, if it asks you the question, what is the maximum velocity, the answer would be 3. What is the minimum velocity? The answer would be -3. But that's not what it's asking. It's asking for speed, which is the absolute value of velocity. Now, this last one has the potential for a lot of confusion. Okay, so let's try to understand one more time that this is the velocity function and what velocity means. The question being asked is, during what time intervals is the body slowing down? Provide an explanation for your answer. This is velocity. Okay, anything that's above the x-axis means you're moving forward. Not increasing, not decreasing. It means you're moving forward. I am moving forward here, 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 and here. I'm moving forward here. Okay, anything under the x-axis means I'm moving backwards. So what this is telling me is I'm accelerating, moving forward. At this moment right here, I am slowing. So pretend that this is a car. I'm driving my car faster, moving forward, moving forward, moving forward. Now I'm still moving forward, slowing down until this moment right here. Okay. Now I'm slowing down, moving forward. This is a slow down, which is a decrease in velocity. So interval number 1, and we'll write it out this way because we haven't written it out this way yet. Interval number 1 is going to be when t is between 2 and 4. Okay. Now, the devil is going to tell you, well, why did you stop at 4? Shouldn't you keep going? No, because now what we're doing, right at this moment right here, by going underneath the x-axis and making our digits larger, we are actually increasing in speed, moving backwards. At this moment, we're stopped. Now we're moving backwards, moving faster. This is not slowing down. This is speeding up. This is staying at the same speed. And here, what we're doing is we're slowing down while going backwards. So the other interval is going to be between 7 and 8 because we're slowing down while going backwards. So the explanation for this is, for the first one, it's positive, the velocity is positive but decreasing. Okay, so velocity is positive and decreasing. And for this next one, we could say that the velocity is negative and increasing towards 0. Now what that means, one more time, what that means, one more time, is since we're moving backwards, okay, we're going from moving backwards at 3 meters per second to 2 meters per second to 1 meter per second to stop. Okay, so the velocity is negative and increasing towards 0, which means you are slowing down while going backwards. So, kind of a bizarre question. Again, not a ton of math, hardly any math at all, really. It's just understanding what graphs look like and comparing velocity to position to acceleration and all that stuff. But yeah, that's free response question number 3. Pretty short and sweet.